Hello, and welcome to the Actual Tech Media Expert Series session on how AI and ML are transforming IT operations. This is going to be a great session about how AI and ML advancements are seeping into every aspect of IT operations and how we can take advantage of them to transform how we run our systems. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get started, I do have a few housekeeping items that I'd like to go through to help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we will discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Second, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of the prize drawing can be found in your handout section. Scroll to the bottom and you'll find the prize terms and conditions link there. Next, I want to thank our sponsor, Sev1, for sponsoring us today and making this event possible. So Sev1 transforms network performance data into intelligent and actionable insights. The Sev1 name came from network manager slang for severity 1 problems in networks, and now Sev1 is using ML-powered analytics from a single source to help you spot, address, and prevent those network performance issues early. This IBM solution goes beyond detection, combining industry-leading expertise and advanced tech to help your IT team plan and optimize your network and act on what matters, network performance management. There's a link there at the bottom of the screen where you can get more information. And I also want to point out the handouts section of your console, which is a spot where you can find a link to this slide about Sev1, which has the link in it as well. And also there's a link to the Actual Tech Media Guerrilla Guide series of books. Those are great books on technology topics written by technology experts. And there's also a link to the ATM Event Center, which is an events calendar where you can find out about more events like this one that you can attend. With that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today, Howard M. Cohen. I've worked with Howard for more than a decade as an editor for his columns on events like this. And the reason that I've worked with him for so long is that, he's got broad knowledge of technology and the business of technology. I'd say it's unparalleled in my experience. There's no one from whom I learn more when he takes on a new technology and spins out the implications and the possibilities of it. So we're in good hands for this overview of AI and ML and what it means for IT operations. Howard, great to have you here.
Hey, Scott, I'm kind of genuflecting in that introduction. Thank you so much. It was wonderful. Okay, let me pick it up from here.
Well, yeah, take it away.
I'm Howard M. Cohen. I call myself a creator of compelling content. After 40 years in the channel, I decided it was time to do something new. And about 13 years ago, I stabbed out to write for and about the channel, do that to this day. And I'm here today to talk to you about using artificial intelligence and machine learning to improve upon and to radically actually improve transforming IT operations, specifically network operations. As a writer, I always like to begin every presentation with a word. And today's word is ops. Now, some of you are sitting there saying, well, that's not really a full word. It's a segment of a word. Don't feel shortchanged. I know it's short for operations, but it's used in conjunction with other words, making it into various different compound words. For example, back in the dark ages when I was in high school and working in the computer lab, we had a connection to the University Admissions Processing Center, UAPC. And one day we got a message. And I said, wow, we never got a message before. What is that? And they explained to me that that's a message from the SysOp. I'm like, what's a SysOp? It sounds like a cartoon monster. And they explained that the systems operator is the SysOp. And if they see a problem on our connection, they'll reach out and tell us what we need to do to fix it. And so I learned about SysOps. More recently, I'm sure everybody here has heard of DevOps. It's as common a word as any in IT. It's basically the combination of the software developers who create the code and the operators who run the code to achieve continuous improvement of the code through ongoing and continuous deployment of the code. And they have to work closely together to get that to go as fast as it possibly can to achieve a level of efficiency. DevOps. At some point, somebody realized that security needs to be involved. And so we got SecOps, security, and the operations group working together. Well, it became very obvious very quickly that the software developers also needed to take security into consideration. So we came up with DevSecOps. And you can imagine this could get longer and longer and longer. If we want to group it all together, you could group it all together into NetOps. And NetOps, in turn, would be part of overall IT ops. And these are terms that are regularly used throughout our industry. I'm going to introduce you today to another one that some of you may have heard of, but it's brand spanking new, and that is AIOps. Yeah, the word that begins with 3 vowels. AIOps. And we're going to talk today about AIOps and how that all comes together. AIOps combines the big data generated by networks with technology that allows machines to learn from it, and using that to automate IT operations and to make everything work better. So the word I want you to focus on in this particular description is anomaly. It's all about detecting anomalies. As you know, that's what all of network management is about. Detect the anomaly and fix it before it becomes an outage. Well, AIOps is going to help us do that. I also wanted to point out before we leave this section that everybody seems to want to hang out with the ops guys. So, buy them a drink. Okay. Next up, let's do a definition of some of these terms, which will help us put everything into context. Let's start with network management. It's a common phrase. We use it all the time. What do we mean? Basically, they're applications that are used to find faults. We look at the network and we try to figure out if everything's running smoothly. Great, we keep going. If something looks wrong, we check it out. We dive deep into it and we resolve it, again, before it becomes an outage, if we can. We also use it to measure our performance, which allows us to improve upon our performance and optimize our performance. It also allows us to report performance, which helps the next time you're requesting budget. And so that's basically what network management is. It's basically performed using platforms, network management platforms or suites of software. We could go into a long discussion about the difference between using a platform and using a bunch of tools. Many engineers have favorite tools that they like to use. The problem is integrating them, getting them to work together. It increases the training curve, it increases expense, and it creates a lot more opportunities for failure. So, we tend to recommend find a platform that does what you want it to do and move ahead with that. Okay, the next term that we've already used that we should define is artificial intelligence, which applies advanced analytics and all kinds of logic-based routines, including machine learning, which we'll talk about later, to interpret events. Now, that's the word I want you to focus on in this description, interpret. For the longest time, we didn't think that machines could interpret things. Machines look at things and say, this is or it isn't. It's 0 or 1, on or off, black or white. They don't do shades of gray. They don't interpret. They can't. Well, they can. And that's what AI is all about. It's the applications of heuristics and probability. Heuristics. I'm here to tell you, heuristics is not new. Back, again, in the dark ages, when I was in school, I studied heuristics. So you have to imagine that's several decades ago. We used a DEC model, PDP-8E, to study heuristics. Some of you may actually remember those. But I'm trying to illustrate how long it's been around. Actually, the term artificial intelligence was coined back in 1955. So the concept's been around for a long, long time. And heuristics was originally defined as software that can improve itself, software that writes its own software for itself and makes itself better. Today, it's an assembly of different technologies that enable machines to interpret, to interpolate, to compare, to draw inferences, things that we never thought computers could do, that they can now do. This is great when you're dealing with big data, because not only can you categorize the data, normalize the data, and so forth, you can also start to look for patterns in the data. You can look for similarities. You can compare and contrast things. For example, in a network help desk situation, you can compare customers and your help desk agents, and the AI can actually determine which help desk agent would be best suited to help each individual customer as they call in. Interesting application. Machine learning is part of it. Machine learning is the part of it that basically takes in all the information, uses NLP and deep learning and all kinds of other techniques that are brand spanking new, and basically turns the data into knowledge, into information, categorizes it, and makes it ready for use by the AI. Basically, in our own terms, we use computers to turn data into information, turn that information into knowledge, and use that knowledge to make decisions. AI goes much further along that path for us, so that we simply need to consult the AI, and all of that data has been completely pre-masticated for us. So it's an exciting opportunity to interact with our technology in a much deeper, much more meaningful way. It also, in the context of network management, it cuts down the time needed to do fault diagnosis. Fault diagnosis usually means interrogating a whole bunch of different data resources to find where something's is in a state that it's not supposed to be in. Machine learning can find that a whole lot faster than we can. Also, machine learning is based on models. We actually give the machine a model, and it's a model that it can improve upon, a model that it can adapt to new situations all by itself. And it uses that model to pull in data and to assess the data. So yes, we have interaction with the machine learning through machine learning models. Big data is pretty simple to define. There are three characteristics of big data that everybody should basically focus on. One is volume. How much data are we moving? How quickly does it need to move? Velocity. And how widely does the data that we're dealing with vary internally? So it's volume, velocity, and variability. Those are the three major characteristics of big data that we deal with. AI and ML will ingest huge amounts of data, comparing data from themselves with data from other sources to create understandings, to identify patterns, to assess the data that they have. Okay, so we have defined network management, we've defined artificial intelligence, and we've defined machine learning. Let's put them into context in network management. Okay, obviously in network management, there are a lot of things that require us to jump, to turn on a dime, and to make things happen quickly. It's a high stress, high velocity environment. We know that. AI has really become very useful in 4 specific areas that are critical to network management. The first is traffic management, the movement of data from one place to another, and that other being the right place for it to be going. To get there, it's going to hop through several different points, several different routers along the way. It's going to make use of DNS and other protocols, and it's going to figure out, is everything going where it's supposed to be going? It's also going to figure out if anything's going where it's not supposed to be going, where it should never be going. AI is very good at this. It can analyze traffic patterns and determine if they're, comparing them to previous patterns, is it consistent or is it not? Is something sending data somewhere where it never has before? If so, why? Is that place forbidden? So forth and so on. Performance monitoring. They say that people don't buy shovels to get a shovel. They buy shovels to get a hole, right? Well, the same thing is true here. You don't buy a network to have a network. You have your network to get data from one place to another quickly and efficiently. And so you need to monitor how quickly and how efficiently is the data getting there. AI can very, very capably monitor that, assess that, evaluate that, and report in a very meaningful way as to how well the network is performing compared to its baseline. Another thing that AI is extremely good at is capacity planning. I'll use the obvious example, storage. And one of the big advantages of cloud is that you only pay for what you actually use. Now, in this context, what that means is, in the old days, if you needed storage, you'd buy a hard drive, and one way or another, you would connect it to your computer or your network. And if you needed a couple of terabytes, you would go up a little higher and buy maybe a 4 terabyte drive. At the time you buy it, you may only have about a half terabyte under management, a half terabyte. That means you have capacity for 3.5 terabytes that you are not currently using. And as a matter of fact, you may not use it for several years to come. All of that time you're paying for it. You've paid for it, but you're not using it. It sits idle. And you don't want anything to ever sit idle. In the cloud, if you need a half terabyte, you simply provision a half terabyte. And capacity planning can tell you you're getting close to a time where you need more, so please provision another 1/4 terabyte or another half terabyte. That's capacity planning. That's real capacity planning, an ongoing process of looking at what is, determining what's going to be, and figuring out what's the best and most cost-effective way to proceed with ordering up the various capacities that we use. And there really is nothing more important than security monitoring, because if somebody breaks into our network, all bets are off. And so AI has become very adept at identifying when something's coming that doesn't look right, coming from a place it shouldn't be, configured in a way it shouldn't be, looking to enter into a place where it shouldn't. AI is very good at that, does it very quickly, very efficiently, and is always on the job. So it's constantly vigilant. Also, ML, I should put in that punch for ML, is proving to be the biggest aid in making all of this happen. ML is ingesting all of this data, pre-chewing it up and making it available to the AI to support all of these functionalities. So the ML is collecting anonymous telemetry. You may be part of organizations that allow you to monitor their data. You may have agreements with commercial sources that will sell you network data that it has collected over multitudinous networks, so you can compare your results with theirs. Yet every network is unique. We're not saying that you should conform your network to the way everybody else operates their network, but what we are saying is that AI can look at something that's happening and compare it to how it happened on other networks and determine what the outcomes were, and then apply the best possible solution to create the best possible outcome on your network. In some cases, in every case, your machine learning algorithms focus on your network. Some of you may be connecting up with other networks in other places to get more data to compare against. And it's advisable to start looking at that, because the more you can compare against, the better sampling you have to make better decisions. And when I say make better decisions, I mean to have your AI making better decisions. Okay. This brings us to the arc of service objective. The arc of service objective. What do I mean by that? Now, back in the earliest days, the name of the game was when you got a service request, you wanted to be responsive to it. So you wanted to respond as quickly as you possibly could. And most of us guaranteed 4-hour response and 2 business day resolution, or whatever we wanted it to be. How responsive you were was a big measure of how well customers thought of you. And so we all endeavored to be as responsive as we possibly could be. At a given point, we developed an appreciation for preventative maintenance. The idea that you should go in periodically and check everything, make sure that everything is in good working order, make sure that anything that might be out of kilter is properly adjusted. And so we became proactive. We got in front of network issues, and this satisfied customers to a much greater extent because they felt like we were really paying attention and not just waiting for things to go wrong. And that was better. Of course, a big, broad stroke of improvement or making sure is not nearly as good as being able to identify that something is going to go wrong. So we see an anomalistic pattern on the network, and we say, gee, in the past, that kind of anomaly has led to this kind of outage. So before it becomes an outage, we fix the anomaly. At that point, we reach the predictive stage. So now we were predicting that problems were coming down the road, and we needed to get ourselves prepared, fix it so it didn't become an outage. Now, in this environment, one of the beautiful things is that we often had to tell the customer what we had done for them because they wouldn't see it any other way. They wouldn't know they ever had a problem. That's bliss. I mean, when you don't know there's a problem, it's great. You're just moving along. Things are happening. Things are working. That's great. But at a given point, the customer may come to think, well, why am I paying these guys? They're not doing anything. We had to report to the customer, hey, you had this anomaly. We took care of that, and we didn't have the outage that you might have anticipated. Then this happened, and then this happened. You talk about your resolutions. This vastly increased the need to have regular update meetings with your customers, which is always a good thing to do. And then in the service business, we started looking at self-healing. And that's where we're going now. We're going to self-healing. That is to say, the AI is looking for these anomalies. The AI is identifying things that are happening now that could cause outages later. And the AI is automatically taking action to resolve those problems before they become outages. Now, we now need the AI to tell us what it did so we can make sure the customer knows. But the point is that we've now accelerated the process because no human is involved at all in noticing that there's a problem. The AI is much more adept at identifying problems throughout the network because, for one thing, it's always on duty. It's always scanning the entire network. And of course, it scans the network far faster than a human ever could. So we've gone from responsive through proactive to predictive, and now self-healing. It'll see the problem, it'll fix it. Which brings us to the big network management challenge. Okay, we've talked about what our intentions are and what our plan is. What is out there that we need to overcome to make sure that we can do it? And the very first thing is the data. Okay, as we said, it's big data. There's a mass of network data happening at every moment. I mean, every packet that goes through your network creates an entry on the network logs. Every stop it makes an entry on the network logs. These are just on and on, even in a minute of network activity, pages upon pages upon pages of data. How can a human being possibly work through that all on their own without tools? And so tools have been developed over the past many years to help us. But now we're taking those tools and really giving them their own autonomy. They are looking at the data. They are assessing the data. They are interpreting the data themselves. So the AI is looking at logs upon logs upon logs of data and coming back with answers. What are the logs telling us? What do we need to be doing next on the network? We are coping with the unbelievable volume of big data coming at us at unbelievable velocity with wide variation. All three characteristics of big data at their max, and AI can handle it a whole lot better than we can. We would prefer to see something that looks more like this, something that looks more like a picture that we can interpret. And in network consoles like this one, we can look at what's going on. The data from the logs has been transformed into information by the ML and then converted into knowledge by the AI and given to us for decision making, if we're even going to go that far. And it's presented to us in a way that's digestible for a human being. And of course, you can point on these charts and dive deeper in by drilling down into the data to get even more meaningful answers. So really, AI and ML have either made it digestible for us or determined what needs to happen and makes it happen all on its own. And this is the beginning of the end result of the AIOps process. What do I mean? The first step in the AIOps process is to go get some fictional monster and have them consume all your chocolate chip cookies. Now, obviously, I'm talking here about data ingestion. Consume mass quantities, those of you who remember the Coneheads, consume mass quantities of data, ingest them. You ingest them from a lot of different places, from commercial sources, as well as your own data, from vendors, from associations that provide this data, from your infrastructure, from the applications you're running, from your cloud providers and other tools. So now you're ingesting a ton of data. You index it, of course, so that it's searchable. You normalize it so that you can work with it. Then it generates real-time streaming analytics that can be displayed on a console like the one we just looked at. Then, of course, it's critical to store all of that data. Why do I say that? Well, it's critical to store it because you want to record everything that happens on the network. Why? You don't know when something's going to go wrong. You'd love to be able to just record the problems, but you don't know when a problem's going to occur. So you don't know when to turn on recording. Therefore, record everything. You record everything, and then when you start to trace back, it suddenly becomes easier. Tracing back is the key. You look at the problem, you trace back from the problem to what caused it, and then what caused that, and what caused that, and what caused that, till eventually you get back to the root cause, and you deal with that. And you make sure that that doesn't occur again. That's basically the process. Yes, AI can do that itself, but it may be that there's something that you want to see yourself and understand yourself, and that will always be available to you, so you should have that. Everything, if you're going to record everything, it's a lot of data. And so you're going to need massive storage. Even more massive because, again, you want to collect comparative data from other sources so you can compare your performance against theirs to understand what outcomes come from what actions. And again, when I say you, I'm talking about your AI. Basically, that's what they do. AIs look for similar issues, come to understand what caused those issues, come to see what outcomes came from various and different reactions to those issues, and come up with the best possible solution. So basically, your AI algorithms get trained across a wide variety of data sets so they can compare all of them very rapidly to your data set and make the best possible decisions. The AI also must learn the network topology. It needs to know where everything is. It needs to know not only how they're connected, what applications are running, where they're running, what domains are in place and what's crossing over domains, but also physical proximity, because we've found over time that physical proximity actually impacts latency. And so the closer the data source is to the data destination, the shorter a path it has to take and the fewer hops it has to take, the better your latency. And so the AI is going to want to know that. And it basically looks at all your IT assets, all the services that you're running, and assesses each of the relationships so that it understands what they look like when they're running well, what it looks like when they're running poorly, and what to do to go from one to the other. Ultimately, the job of these AIs is the same job that we as network engineers have always had, which is event correlation. Why did this happen? It looks like it happened because this and this happened. Why did these things happen? Because these things happened. And you go further back and further back. And again, it's root cause analysis, getting back to the first thing that happened that started all of this going. And what do we need to do to make sure it doesn't happen again? Fortunately, with AI, we get left out of the equation more and more. You don't have to have people poring over logs to see every activity that occurred, to seek out different locations along the network, different network IP addresses, and so forth. That is painstaking work, and I'm emphasizing pain. It's very painstaking work. So basically, you're forming the correlation between time and topology, and coming to understand what events look like by grouping them, analyzing them, comparing them, and learning from them. The science by which we do this, of course, is pattern recognition. In the case of the logs, the AI is examining the pattern of data traffic, comparing it against the patterns of other data traffic to understand what it looks like when it's working well versus what it looks like when it's working poorly. And then it refines those patterns in terms of its operation. It can actually take action to improve upon, to align its patterns with the best performing patterns it has seen, and then therefore get to an optimal condition. As I said at the very beginning of this presentation, the name of the game is anomaly detection. Which of these things is not like the others? We're looking at normal behavior across many different data sets. And then we're seeing when our network departs from what normal behavior looks like. When it does, we're correlating that with the impact it has on the business and other processes so that we can create a productive response rather than just simply creating a response that may not really be very helpful. So anomaly detection is really the name of the network management game. Finally, after we've looked at all this data, tons of data, we've analyzed it, we've correlated it, we've interpreted it, we've done anomaly detection, we've done all of this stuff. All of it is useless unless we provide remediation. Today's platforms, you need to demand that they not only identify the problem, but they have the tools built right there so that you can immediately go fix them. Remediation is the key. It's what we're here to do. And so we either tell an operator, go do this, or the AI does it itself automatically. One or the other. That is the ultimate end result of AI and ML functioning in network management. The goal at the end of the day is for us to have autonomous networks that keep on running without worrying about us. They don't need us. You know, some of you will remember a grand example of such a computer, and here it is, the HAL 9000. Those of you who have seen 2001: A Space Odyssey, and I hope you all have, will remember the heuristically programmed algorithmic processor, HAL, the HAL 9000. And HAL not only was able to do things aboard the Discovery, but it was also able to tell us when it could not. We remember it saying, "I'm sorry, Dave. I'm afraid I can't do that." Now, hopefully your AIs and MLs won't do that to you and your network. But that's a general overview of how AI and ML are being applied to the task of network management to improve networks and improve network performance. And with that, Scott, do we have any questions from the group?
Yeah, and before we get to that, since it's Friday, let's have a little fun as we start this Q&A portion. So we want to know, what's your favorite general purpose AI from fiction? You know, Howard just made that reference to HAL 9000. You know, my favorites are probably Murderbot from the Martha Wells series of novellas, but also a fan of Jarvis from Iron Man and Jane from the Ender series. But let us know your favorites in the Q&A. Love to see that. Howard, first question for you. What's the difference between the current state of machine learning and AI in network management tools, and then just sort of smarter programming and improved processing power? Is there a way to think about that?
Well, AI and ML are a component of improved processing functionality. It's interesting. You mentioned that I've been at this for over 40 years. One of the things that keeps me completely intrigued by IT is that there are constantly things happening that we just don't yet understand. There's somebody out there who understands them. They're developing them. But even those of us who are in the industry practicing, delivering these services, AI and ML, I think, are as opaque right now as any of those technologies have ever been. Unless you're involved in development, it just is nothing short of remarkable. We used to say that you can't get a computer to generate a truly random number. Ultimately, it has to all trace back to an algorithm. That's really no longer true. We found ways to get computers to do imprecise things. And that, it goes against everything I was taught from the very beginning of my involvement with technology. So I think, as we apply these things to network management tools, I will say that I think the best network management platforms and tools are the ones that really bring it all together, where the interface is consistent, where the path from problem identification to problem resolution is as short as possible, because the demands that users place upon network management are huge because it keeps them working. And so we have to find ways to keep on stepping up to it.
Okay. Yeah. Great. And we've had a couple of answers so far on the AI. Zahab is saying Cortana. Hanan has a vote for Jarvis as well. We got a question from Janal who's asking, what's your thought on the combined power of AI plus ML plus quantum computing?
That's something of an apples and oranges comparison. Quantum computing is a processing technology, approaching the idea of getting a computer to do what it does in a radically different way that is infinitely faster and more efficient. AI and ML are applications. No matter how you slice and dice it, they're applications. They have nothing to do with the actual physical process of computing. Hopefully, at some given point, quantum computing gets applied to run AI and ML, and then I think we have reason to be afraid, to be very afraid.
Yeah.
Oh, by the way, my vote for the favorite AI in fiction is the original computer from Star Trek, Majel Barrett's voice. That by far it was the most useful AI of all time to me.
True. Yeah. And Bradford puts in Whopper, which is the one from War Games. That was a terrifying one. So another question for you here is: so you talked about the emerging concept of AIOps, and I know that you've spent a fair amount of time on other projects thinking about sort of the organization of IT departments. What does an AI ops team look like? Which part of the organization are included? What are some of the job titles there?
I think a lot of the positions are the same. Some positions will disappear. That's something that we have to wrap our heads around, is that eventually we won't need as much headcount because a lot of the routine day-to-day tasks, the repetitive tasks, will be replaced by automation. I think that interesting. There are two characters that I think get added to the team that actually align very well with the team that you would build for multi-cloud. One of them is a software developer on the network management team who has the ability to interact with the AI and ML software to improve upon it, to build models for it, to improve those models for it. We are at a place where we need to communicate very directly with the AI software itself to get it working better for us. And so for the first time, we're really going to need a real sophisticated software developer to do those functions. Also, I think we're going to need to have financial management on the network management team, in that a big part of AI and ML improving network management is that it makes it more cost effective. Well, if you say you're going to make it more cost effective, you damn well better be sure that at the end of the day it is. And so you need somebody analyzing that constantly. Is what we're doing saving us money? Are there other ways we could be saving more money? Are there other applications of AI out there that we're not taking advantage of that could help us save even more money? Everybody on the team right now is pretty much technical in nature. You're going to need people from the business side, from the financial side, because part of running It's the old make it work better, make it work cheaper equation. You need to be able to show that you are making it work less expensively.
Gotcha. And we have a question here from Ned about anomaly detection. He's wondering, does anomaly detection working in tandem with AI and ML better support security monitoring within an organization?
Absolutely.
Is anomaly detection one of the areas where AI and ML shine?
It is the area. It's at the nucleus of that area, in that, think about everything we talked about today. You're looking at a broad variety of patterns of data from a lot of different networks, tracing from the inception of an activity through an anomaly that occurs, the resolution to that anomaly, and the outcome that it produced. You're looking at all of them and comparing all of them against your own. The whole purpose of doing that is so that you can identify when something's happening in an abnormal way, which is the definition of anomaly. When you can identify it that quickly, you can resolve it that much sooner. And in today's networks, that's the key to competitiveness. The faster you can resolve a problem, the sooner people can get back to work, the better off you are. So anomaly detection is what it's all about. And AI and ML improve and accelerate our ability to identify anomalies far faster than ever before.
Gotcha. In probably the last question for you, Howard, as we're getting ready to wrap up here. I had asked you about AIOps teams and sort of reorganizing, the organization around AIOps. Conversely, are you finding that the tools are getting good enough at implementing AI and ML that organizations can get good value out of them without necessarily needing, say, data science experts on staff, to tune them effectively?
Everything in my soul is telling me to say no. I don't think we're there yet. I think that the category of AI and ML, even though we've been talking about it for 66 years, since 1955, 67 years. That's a particularly important number to me personally. It's still in its infancy, and therefore it absolutely requires expertise to use in this context. I will say that there are other contexts in which AI can be used by anybody. There's recommender engines that are available for retail businesses, where they compare all of a company's products with all of a company's customers and figure out which products are best to recommend to each customer. And then the AI basically sends them promotional material. It's literally doing highly targeted marketing for you based on the wants and needs of each individual customer. That is now a mature enough product that any business can put it into place and use it. As long as they, quote unquote, follow the instructions, they will get results, good results. And of course, we all have Cortana and Siri and Alexa and others, Google Assistant. We all operate them, some of us better than others. But AI is that kind of a technology. It's being used in a broad spectrum of applications. I think in network management, it's still in its infancy, but we're getting better and better. And soon there will be commercial products that you can simply implement and put into use without needing that kind of assistance. But I don't think we're there yet.
Okay. Yeah, and Paul's got a sort of a follow-up question to exactly the answer that you were just giving. He's saying, is there guidance or rules of thumb that can help a company determine their IT infrastructure and ML AI implementations, whether they require AIOps to help support? Is there, is the tipping point usually about staffing bandwidth versus IT infrastructure management? Any thoughts on sort of rules of thumb or when you're ready for an AIOps team?
Congratulations on a great question, Dan. That's a great question. I think that the companies that are providing AI and ML solutions would like to say to every network needs this. That's a very easy answer. But is there a tipping point? I think that's the key. Is there a place before which you're not really going to get enough return to warrant the expense? I certainly have done no evaluation of where that tipping point is, but I'm fascinated by the concept that there is one. I think there certainly is one. I suspect that it's related to, the size of your network. That if your network is X number of nodes, you're not really going to generate enough traffic to warrant this level of depth in analysis and responsiveness. I think that that's arguable. I think that even the smaller network operators could identify value that they would derive from it. But again, it's always that balance between functionality and budget. And the fulcrum point, I don't think it's been identified. If it is, I certainly don't know it, but I love the question.
Well, Howard, I think that's a great place to leave it. Thanks so much for this presentation. It's been really thought-provoking, and appreciate all your answers here in the Q&A portion too. As always,
My pleasure,
brought
Scott.
us, a lot to think about. Yeah.
No, I was just saying I thank you for leaving us on a stumper.
I think it's the only realistic way to leave something, a topic as big as this. So, yeah. Thanks again, Howard. And before we wrap up, we do have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of today's gift card is Sahidi Gala from Kansas. So congratulations to Sahidi. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Sev1 for making this event possible, and Howard again for presenting. And I want to thank all of you for coming on and for all your great questions and for your answers on your favorite AI. So have a great Friday, great weekend, and we'll see you all next time.